I'm going to show you the QCT service assurance framework, including the data collection method and displaying method and our event-driven actions that is used to achieve the self-adapting abilities. Next, I will review some outcomes of our works, including some system snapshot and our UIs. Finally, is my brief conclusion. With the growth of the complexity of the network functions, that it is more and more difficult to take care about all the statistics, such as the physical infrastructure, including the physical infrastructure, such as the CPU utilizations and fan speed and temperature. And the most complex part is the VNFs, statistic from the VNFs, including the EPC workload, or some statistics from web server, such about that, something like that. All the statistics should be taken care about by the administrator, and it is also so as a result, the administrative overhead is heavier than before. So we proposed the we proposed an use case for code called QCT Service Assurance Architecture and called QCT-SA to reduce such administrative overhead. The monitored element including the QCT hardware, including the NFVI, for example, the OpenStack and VNFs. We also gave the system intelligence through the data analysis and events. QCT-SA proactively notifies the events when it detects or it finds the abnormal behaviors of the system. Through these two methods, and we can let the system self-adapt the behavior to achieve the closed loop automation. Our goals are, sorry about that. Our goals are monitor everything, including QCT servers, switch, storage, and racks, NFVI, and VNFs. We also provide an UI to display the data and events, event notification, and the data analysis used for the self-adapting and maintenance. QCT also provides architectures and API to speed up the developments, if vendor want to build their own service assurance architecture, vendors can also co-work with QCT. We can develop integrate telemetry APIs with vendors, and we can also design telemetry metrics and alert rules and policy action policies with the vendors. Also, if the vendor want to go further, we can customize a dashboard for particular VNFs. This is our QCT code-ready part system architecture based on the QCT code-ready part system, code-ready part that is built by QCT hardware, including server and switches. And we also onboard several commercial workload on it, such as the R3 EPC solutions, and that is the EPC workload, and we want to generate some traffic to that. For that, we also onboard a packet generator to generate the packet, to generate the traffic. Okay. We also onboard our QCT-SA architecture to that to monitor entire infrastructure and all the applications. Okay, here is the QCT-SA architecture. First, the QCT-SA collect the data first. The QCT-SA collecting the data from the core, from the QCT core ready part, including the QCT infrastructure, NFVI, for example, the OpenStack, and all the VNFs and the commercial VNFs. Then the QCT-SA will process the data and store the data to the database. If it finds any abnormal behavior, the system alerting send the data to the event alerting send the alert to the administrator to inform the administrator that the system has some problems. And the dashboard is used to uses the stored data to display the statistics to the administrator. And our QCT-SA also generates some events. Okay, generate some event if it finds some abnormal behavior or statistics. The event will be sent to our policy engine of our monolith system. The policy engine will match the rule and find the actions to overcome the problem. Then that is generate some actions to our VNF and the infrastructure manager. The VNF and the infrastructure manager will reconfigure the VNFs, including our commercial VNFs, to adjust the performance or behaviors, or the VNF and the infrastructure manager send the control to our NFVI to scale in and scale out the VNFs. And also, it can send the configuration to our QCT infrastructure to scale in and scale out the hardwares. This is the QCT-SA deployment type. We provide two deployment type of the QCT-SA. One is the cluster collect D cluster type, and the other is the collect D agent type. Okay, we build the collect D cluster, and we develop several kinds of the collect D plugin to get the statistic from the NAVI, including EPC plugin that is specific for the R3 commercial EPC solution, and the QCT plugin and can get the statistic from our QCT hardware through Redfish API and IPMI and something like that, and some OEM APIs. And VNF plugin that can be used to get the statistics from some services, such as the web service, load balancer, something like that. All the data collected by the collect D, and then the data will be delivered to the exporter. Finally, the exporter will write the data to the time series database. In this case, we use Prometheus database. The agent type. Means that the collect D can be installed into the VNFs and the servers directly. And then the collect D get the statistic from the VNF services or from the operating system directly. Then the data will be delivered to the exporter and write to the database. Now we are talking. About the. I'm going to talk about the this data display and the event-driven actions. First, Collective must collect all the data for data processing from the VNFs, NFVI, OpenStack, and our QCT infrastructure. The Collective will write the data to the database and send the data, deliver the data to the alert manager. The alert manager will process the data to find any abnormal behavior of the systems. If it finds the abnormal behavior of the system, it will send alert messages to the administrator through SMS or email, something like that. Or alert manager also generate also send the events to the policy engine, and if there's any abnormal behavior, something like system overload, CPU usage too high, the policy engine will match the rule and find some solutions, and then generate the action, send to the VNF and the infrastructure manager to adapt, to adjust the system behavior. Also, the Grafana-based, we proposed a Grafana-based UI to display the data stored in the database. And this UI is designed for displaying some important indicators. Now we are talking about the VNF infrastructure manager. That is an abstraction layer of the device configuration. As far as we know, all the configuration method of any system is quite different. So, an abstraction layer, we expected that we provide a common interface for VNF and infrastructure configuration. It also can be used to isolate the VNF control plane from the public network and to increase the security. We expected that using a common REST API to deliver the configuration to the heterogeneous systems, as far as we know, such as the EPC VNFs, OpenStack, and our QCT infrastructure. Maybe we provide the RSD API, IPMI API. Those configuration methods are different. So we expected that using a common REST API to reduce the configuration complexity. Now we are talking about the closed loop automation in code. First, we must collect all the statistics from the NFVIs, including the VNFs and PNFs and infrastructure. Then all the statistic data is delivered to the data analytic engine and the events. That is used to processing the data and analyze the data to find any to recognize the system behavior. If it finds any abnormal behavior, an event is delivered to the policy engine. According to this event, the policy engine will select some actions to adjust the system behavior. Then the action is delivered to the infrastructure controller. Infrastructure controller is used to interpret the action to the particular to the command for particular devices or services, and then use that command to configure the NVI. to adjust the entire system. So we expected that through this closed loop automation, we can achieve the auto-scaling ability and the self-healing ability and optimize and the service performance or stability optimization. Now we are talking about the dashboard map. Through the visualization layer, we provide 5 categories of the 5 category display in homepage that is used to display the core architecture and the system architecture. The overall summary is used to display the NFVI resources, the EPC throughput, and some logs. All the important value and logs is displayed here, are displayed here. NFVI, this page is used to display the NFVI statistic, including the CPU utilization, memory utilization, and network throughput, something like that, and also the system errors, fault, any information are displayed here. The EPC category is used, that is the customization UI for a particular R3 EPC workload. And that is used to display the uplink and downlink throughput and subscriber count, also the forwarding rate. Sitemap is used to display the location of the data of the base station, and we also use the hotspot to indicate the system loading. Okay, here is our QCT-SA onboarding to the core. Through the XOS UI, we can observe that this blue circle is the R3 EPC solution, and the red circle is our QCT-SA architecture, that including our Collective cluster and Prometheus cluster in the system. Next, this circle is the package generator. Okay, now I will review some system snapshot of our work of our QCT-SA. This is the overall summary page, and actually we display 2 types of services. This is the fixed line statistic and provide the fixed line network service. This area is the R3 EPC workload statistic, and the most important of these 2 services is the traffic load. So we can see that the total network load and upload and downlink speed, and a graph to display the traffic loading. And at the bottom, this area, we show the operation log. If the system have any errors, that will be displayed here. At the right-hand side is the NVI usage, and it is used to display the CPU usage, memory, network, storage usage, and also the network throughput to let the administrator observe the usage, the system usage, and the network throughput. Here is the here is the NFVI, the UI of the NFVI category. We can see that each that can be used to display the status of each servers. And we can observe that the CPU usage, memory usage, and the network load. Also, at the right-hand side, this area, that is the CPU usage summary and the memory usage summary. At the bottom here, that is the service status indicator. If QCT-SA find any errors, the icon will be marked red. And this area is the system log. Here's my conclusion. We propose a service assurance framework and integrated with the core, including statistic monitoring, alert system alert, and event-driven actions that is used to provide self-adapting abilities. QCT provides the APIs and architecture. If vendors want to build their own service assurance architecture, the vendor can refer the QCT-SA and use our API to speed up their development. And the vendor want to collaborate with us. We also can customization some UI and monitor measure for that VNFs. We also get the system intelligence. So we provide alert system and the data analytic and the event-driven action to let the QCT-SA can self-adapt the system. And we provide an UI to display the iconic statistic of the system to let the administrator to observe the system status. For more detail, QCT is going to hold an NGCO event in QCT Solution Center in San Jose at January 24th, 2019. The topics range from 4G, 5G vRAN at the edge, VNF accelerating data plan by FPGA P4, to NFVI reliability testing. And we are pleased to invite you to join us and registration by this GUE19 code and scanning the QR code to register the events. Thank you for your all attention.
Thank you, Kate. Are there any questions for the presenter?
Is this solution a pure software solution, or are there hardware components, for example, for packet generation?
This solution is pure software solution, so we can onboard the solution to the core, or yes, for monitoring entire core system, yes, without any hardware added. Okay.
Are there any other questions? Okay, thank you.
Thank you.